Good morning, dear students. In this video we will discuss about the important concepts of the chapter solid state. So from this chapter you don't get any 1 mark question. Okay, from this chapter you will get only 7 marks. Total weightage of the chapter is 7 marks. Among the 7 marks they will ask one 2-mark question and one 5-mark question. Okay, one 2-mark question and one 5-mark question. This 5-mark question is not a direct question. It may be asked for 3 plus 2 or 2 plus 2 plus 1 in this manner. So that means one 2-mark question, one 5-mark question you will get from this chapter. So we will make a look in which way they will ask the questions. The most important concepts of the chapter is first one, differences between Schottky and Frenkel defect. Next, differences between crystalline and amorphous solids. From these two there is a chance to ask one question for 3 marks, either between the differences of Schottky and Frenkel defect or the differences between crystalline or amorphous solids. Next, another important question, packing efficiency in FCC, BCC or SC. Face centered cubic structure, body centered cubic lattice, next simple cubic lattice. Among the three, one is compulsory for 3 marks. Okay, so packing efficiency, based on packing efficiency they will ask one 3-mark question. Next, calculate number of particles in SC, BCC and FEC. So here this is different from this question. Here we need to find out packing efficiency, but here we want to calculate number of particles. Okay, number of particles in simple cubic cell, body centered cubic cell and face centered cubic cell. This is very much important for 2 marks. I already told you that from this chapter you will get one 2-mark question. So frequently they are asking that 2-mark question by calculating number of particles in this. Okay, next, another important question is important definitions present in this chapter, that is what is unit cell, what is the coordination number, what is anisotropy, like that kind of definitions can be asked. And next one, most important one, problems based on density or number of particles present in FCC, BCC and SC. So especially this is the concept where the numericals based on density or number of particles, density or number of particles. From this compulsory you will get one 2-mark question or 3-mark question. And next important questions are, what is anisotropy, what is coordination number and what is unit cell. So these three are the 3 questions important for definitions, either for 1 mark or for the 2 marks. Okay, next one, what is coordination number in simple cubic, BCC and FCC. So that is also important for either 1 mark or 2 mark. Next one, mention the constituent particles in ionic solid, covalent solid and molecular solid, and give one example for each one. Next one, name any 2 crystalline systems or crystal systems. Just names you want to write. What type of crystalline solid is graphite? Graphite belongs to which type of crystalline solid that we want to mention. Which type of forces exist in ice? The type of forces present in the ice you want to find out. So these are the most important concepts where you will get questions either for the 2 marks or for the 3 marks. Now we want to see the formulas to find out density. Based on density, so you will get questions for numericals. For that, what are the formulas we need to follow, that we will discuss now. So here are the few important formulas to find out density as well as radius of a system or cell. First, formula based on density. Density numericals can be asked based on the density. So density is always indicated by either D or it is indicated by rho. Density is indicated either by D or by rho. This D is equals to Z into M divided by A cube into Na. Density of a cell is always equals to Z into M divided by A cube into Na, that is mass of the unit cell divided by volume of the unit cell. So mass of the unit cell is always equals to Z into Ma. Volume of the unit cell is always equals to edge length. of the unit cell. So by substituting those two values, density formula D becomes equals to Z into M divided by A cube into Na. So first we want to know what all these letters indicates. D indicates density of the unit cell. D indicates density of the unit cell. Z indicates number of atoms present in that unit cell. Z indicates number of atoms present in that unit cell. So there are three different unit cells in your syllabus, that is simple cubic unit cell, face centered cubic unit cell, body centered cubic unit cell. So for simple cubic cell, that Z value is 1. Z is nothing but number of atoms. Number of atoms in simple cubic cell is 1. For BCC it is 2. For FCC it is 4. This you want to remember while calculating problems based on density. Okay. SC, Z value for SC is 1. Z value for BCC is 2. Z value for FCC is 4. So this you want to remember. Z is nothing but number of atoms per unit cell. Next, M. M is nothing but molar mass of the unit cell. Molar mass will be given in the problem itself, need not to worry. You want to remember only Z value. Next, A. They have given A. A is nothing but edge length. A is nothing but edge length. Next, Na. You know Na. Na is nothing but Avogadro's number. So Avogadro's number value you know, that is Na is equals to 6.022 into 10 to the power of 23. 6.022 into 10 to the power of 23. This is constant value. Na value we know 6.022 into 10 to the power of 23. And Z value also you know for the three different types of unit cells. By substituting these two along with M and A, you will find out about D. Okay, if D is given, we can find out M. If D and M is given, we can also find out edge length of the unit cell. Like that we can easily find out. The formula to find out density of a unit cell is always D equals to Z into M divided by A cube into Na. Clear? So I already told you that density can also be indicated by one more symbol, that is rho. Rho is equals to Z into M divided by A cube into Na. A cube sometimes will be given in meters or picometers. A cube is given in picometers. To convert A cube into centimeters, you want to multiply it with minus 10 to the power of minus 10. So anyhow we want to cube it. So A cube into 10 to the power of minus 10 cube is nothing but 10 to the power of minus 30. That I have written directly here in the form of centimeters. Okay, if it is given in picometers, we want to convert it into centimeters. 1 picometer equals to 10 to the power of minus 10 centimeters. Whenever you cube it, because A cube is there, when you are cube it becomes 10 to the power of minus 10 cube, it becomes equals to 10 to the power of minus 30. If you have any confusion, you just leave this formula and you just remember this formula and terms present in this. Now one more. See, if edge length is given or A value is given, you want to find out R value. R is nothing but radius of the unit cell. Okay, A is edge length, R is radius of the unit cell. A for SC, simple cubic cell, A is always equals to 2R. For face centered cubic cell, A is equals to 2 root 2R. 2 root 2R. For BCC, A is equals to 4R divided by root 3. 4R divided by root 3. So if R value is given, by that we can find out edge length for the three different types of unit cell. If suppose A value is given, you want to find out R, then what happens? For SC, this R becomes equals to A by 2. R comes this side, A comes this side. R equals to A by 2. We can use this formula. Then for FCC, R is given, A is given, you want to find out R. Then R becomes equals to what? A by 2 root 2. A by 2 root 2. For this FCC, R equals to A comes this side, A divided by 2 root 2. Okay, for BCC. For BCC, R is given, you want to find out, A is given, you want to find out R. When R comes this side, R is equals to cube root 3 divided by 4 into a. Root 3 divided by 4 into a. So that means if edge length is given, you can find out r value. If r is given, you can find out about a value for the three different types of unit cells. You need to remember this formula, that is density D equals to Z into M divided by A cube into Na. If edge length is given in picometers, you want to convert it into centimeters. 1 picometer is always equals to 10 to the power of minus 10 centimeters. If radius of a cubic cell is given, you have to find out edge length A. For the three different types of cells, the formulas are different. Okay, just remember these formulas as well as this formula. Here M is nothing but atomic mass or molar mass of a substance or unit cell. Z is nothing but number of atoms present in the unit cell. Z value for Se is 1, Z value for BCC is 2, Z value for FCC is 4. And edge length is given in the formula. Na value is a constant value, that is 6.022 into 10 to the power of 23. So then by knowing all these, you want to find out D, or if D is given, by that you want to find out M value. Either of the question can be asked, either for 2 marks or for the 3 marks. Now we'll solve few numericals based on this density formula. If you want, you can take a screenshot of these formulas. Okay, this will be helpful for you while solving the numericals. You just want to remember these formulas, that is enough for the numericals based on density. Here is our first problem based on the density. See, they have given a question based on density. An element having atomic mass 108 unified mass has FCC or CCC lattice, FCC or CCP lattice. The edge length of its unit cell is 408 picometers. Your edge length is given in picometers, we want to convert it into centimeters. Calculate the density of the unit cell. Question is calculation of density. Okay, density D is equals to Z into M divided by A cube into Na. This is our formula to find out density. First, write down the data whatever is mentioned in the problem. Here they have mentioned the unit cell type, that is FCC. For FCC or CCP, Z value is always equals to 4, that never changes. Then write down atomic mass. M value is given, that is 108 unified mass. M value is equals to 108 unified mass. Okay, next. Then what they have given, edge length. Edge length of the unit cell is 408 picometers. Edge length is given by A. A equals to 408 picometers. You want to convert it into centimeters, so multiply it with minus 10 to the power of minus 10 centimeters. Okay, picometers have to be converted into centimeters. Now Z value is given, M value is given, A value given. Z, M, A. What we want to know? Na. Na value I already told you, that is Avogadro's number, which is constant, that is 6.022 into 10 to the power of 23 particles. That is about the Avogadro's number. Now we want to find out density of the unit cell. What is Z value? 4. Substitute here. Into M value 108 divided by A value. Edge length value is given 408 into 10 to the power of minus 10. You want to cube it. So individually I am cubing 408 cube into 10 to the power of minus 10 whole cube into Na. What is Na value? 6.022 into 10 to the power of 23. Okay, now do the calculation. See, after calculating 4 into 108, you will get 432. Okay, then 408 cube value by multiplying with 6.022, you will get this much value. And 10 to the power of minus 10 whole cube equals to 10 to the power of minus 30 into 10 to the power of 23. I am taking as it is, and you know this value. 10 to the power of minus 30 into 10 to the power of 23 is nothing but 10 to the power of minus 7. This value is 10 to the power of minus 7. By dividing these two values, 432 divided by 408,998,052.8, you will get 1.0562 into 10 to the power of minus 6. By dividing these two, you will get this value. 10 to the power of minus 30 into 10 to the power of 23 is nothing but 10 to the power of minus 7. This denominator minus 7, when comes to numerator, it becomes plus 7. 10 to the power of plus 7. So 10 to the power of 7, 10 to the power of minus 6 becomes equals to 10 to the power of 1, that is 10. 10 into 1.056 is equals to 10.562 gram per cubic centimeter. Okay, this is our answer. Clear? Finally, we got this value. Understand? So this is about the density of the unit cell. Now we'll see the next problem based on density. An element crystallizes in FCC lattice if edge length of the unit cell is 408.6 picometers and density is 10.5 gram per cubic centimeter. Calculate the atomic mass of the cell. So here it is completely based on density value is given. You want to find out this atomic mass. First, write down the formula for density. Density is equals to Z into M divided by A cube into Na. This is the formula for density. But here density value is given. You want to find out this atomic mass M value. Then M becomes equals to density into A cube into Na divided by Z. Okay, this is the formula to find out atomic mass. First, write down the data whatever they have given. So here they have mentioned FCC. FCC, if it is unit lattice cell or unit cell, then Z value is always equals to 4. Okay, next, edge length they have given. Edge length is nothing but A value. A value is equals to, edge length is 408.6 picometers. They have given in picometers. Convert it into 10 centimeters. So multiply it with 10 to the power of minus 10. Then density of the unit cell they have mentioned, that is 10.5 gram per cubic centimeter. D equals to 10.5 gram per cubic centimeters. Okay. Now Na value is a constant value, that is Avogadro's number 6.022 into 10 to the power of 23. Now we know all the four except M value. Now we want to find out M by using this formula. Substitute all these values in the formula. M is equals to D value. What is D? 10.5 into A value 408.6. 408.6. So cube into 10 to the power of minus 10 cube into Na value, that is 6.022 into 10 to the power of 23 divided by Z value. What is Z here? 4. You just do the calculation. After doing calculation, you will get nearly the value, that is 1. So first 107.8 unified mass. After doing this calculation, you will get this much of atomic mass. What is atomic mass of the unit cell or the element present in unit cell? That is 107.8 unified mass. That means if density is given, based on the density you can easily find out atomic mass of the unit cell. Now here is our next problem, that is niobium crystallizes in a body centered cubic cell, it is BCC structure, and its density is given, that is 8.55 gram per cubic centimeter. Calculate atomic radius. We want to find out atomic radius of the unit cell. Atomic radius is nothing but R value we want to find out. To find out R value, the relationship R value for finding this body centered cubic structure, formula is root 3 divided by 4 into A. This is the formula to find out atomic radius for BCC. So to find out R value, first you want to know edge length. Edge length can be calculated from the formula density. Density D is equals to Z into M divided by A cube into NA. But now here we want to find out A cube first. From this A cube you want to find out A. From that A you want to find out radius. First separate this A cube. Now A cube becomes equals to Z into M divided by D into NA. This is the formula now to calculate A cube value. First, write down the data what they have mentioned in the problem. They have given body centered cubic structure. For that Z value is 2. Now density is given small d, that is 8.55 gram per cubic centimeter, as well as atomic mass also given, that is M value 93, and Na we know that is Avogadro number 6.022 into 10 to the power of 23. By knowing all this we can easily find out A cube. Substitute in the formula. Z value is 2 into atomic mass M value is 93 divided by density D value is 8.55 into Na value 6.022 into 10 to the power of 23. So first calculate all this. Okay, by calculating all this you will get 3.613 into 10 to the power of minus 23. When this 23 comes to numerator, it becomes minus, positive becomes negative. So 10 to the power of minus 23 as the value for A cube. From this you want to find out A value. A value is equals to cube the root of 3 into 3.613 into 10 to the power of 23. Okay, by using that value here, you just find out R. R is nothing but radius. First find out from this, find out A value, then R equals to root 3 divided by 4 into A. Multiply this value with this and you will get R value, that is atomic radius of the unit cell. That is atomic radius of the element, that is niobium. So here this kind of questions can also be asked for either 2 marks or 3 marks. Now see the next problem. Aluminium, Al is nothing but aluminium. Aluminium crystallizes in an FCC structure. FCC structure, atomic radius of the metal is 125 picometers. Atomic radius they have mentioned. Okay, calculate the edge length of the unit cell. Edge length is indicated by A. Edge length is indicated by the letter A. So now we want to find out A for which unit cell? FCC. For FCC unit cell, A value is equals to 2 root 2 into R. In the starting of this video, I have given the formulas for edge length, radius as well as density. From that I have taken. Edge length of FCC is always equals to 2 root 2 into R. R value they have given. What is R value? Atomic radius value is 125 picometers. Atomic radius value is 125. You just substitute that R value here. That is 2 root 2 into 125. 2 root 2 value. Root 2 value you know. That is 1 point something. Multiplying with 2, you will get, we'll do the calculation. Here you can see root 2 value is 1.412. This is root 2 value. 2 into root 2 value you will get 2.828 into R. What is R value is given in the problem? 125. So by multiplying all this completely you will get 353.55 as A. That is edge length of the unit cell. If radius is given, based on that you will find out edge length. If edge length is given, atomic radius we can easily find out. And we'll see the next question. So here is another question. An element has BCC structure. The unit lattice is BCC with the edge length of 288 picometers. Edge length is nothing but A value, that is given as 288. Then density of the element is given as 7.2 gram per cubic centimeter. and you want to find out how many atoms present in that present in 208 grams of element. First you want to find out m value for this. So first density, d equals to z into m divided by a cube into na. This is the formula. First write down whatever the data given in the problem. So for BCC, z value we know that is 2. Okay, next edge length already given, that is 288 picometers. Edge length is indicated by a, that is 288 picometers. When it is converted into centimeters, multiply it with 10 to the power of minus 10. Picometer is converted to centimeters. Then density of the element is given 7.2, d equals to 7.2 gram per cubic centimeter. Next, how many atoms are there we want to find out. Before that, first we want to find out m. M is not given atomic mass. If you know its atomic mass, from that atomic mass we will find out number of particles present in that or number of atoms present in that. First find out m here. Then m is becoming equals to a cube into na into d divided by z. This is the formula. Okay, now substitute the values. What is a value? 288 whole cube into 10 to the power of minus 10 whole cube into na value 6.022 into 10 to the power of 23 into d value. D value is given 7.2 gram per cubic centimeter divided by z value. What is z value? 2. Okay, by multiplying all this, by multiplying these two, you will get 1.035 divided by 2. 10 to the power of minus 10 whole cube is 10 to the power of 30 minus 30. 10 to the power of minus 30 into 10 to the power of 9 you will get here. By cubing this and multiplying with this, you will get 1.035 into 10 to the power of 9. 10 to the power of minus 10 whole cube becomes what? 10 to the power of minus 30. 10 to the power of minus 30 into 10 to the power of 23, you will get 10 to the power of minus 7. Okay, 10 to the power of 9 into 10 to the power of minus 7, how much? 10 to the power of 10 to the power of plus 2 or 10 square. By dividing these two, you will get 0.5175 into 10 to the power of 2 or 10 square. We can also write it 51.75 unified mass. This is m value. Now we have found m value, that is 51.75 unified mass. Then this is first method, atomic mass you got. By knowing atomic mass, you want to find out number of atoms. Second one, this 51.75 grams of element contains 6.022 into 10 to the power of 23 atoms or particles. In this amount, these many particles or atoms are present. Then in 208 grams, we want to find out number of particles. Then 208 grams gives rise to how many particles? This is our question. Okay, so you want to find out number of atoms present in this. So cross multiply it. Then 6.022 into 10 to the power of 23 into 208 divided by 51.75. 51.75. Do this calculation. After calculating all this, you will get 24.20 into 10 to the power of 23 atoms. Okay, this will be the final answer. That means 208 grams of element contains these many atoms. whereas 51.75 grams contains these many particles or atoms according to Avogadro number. That means if atomic mass you know, by that you can easily find out number of atoms or particles present in that. Okay, so atomic mass can be calculated by using the formula density is equals to Z into m divided by a cube into Na. Na is a constant. Z value changes from one unit cell to another unit cell. M value, m becomes equals to a cube into Na into d divided by Z. Okay, so in this way also we can find out about the number of atoms or particles present in the given amount of element. See here, there are two more problems. Okay, so first one, silver forms CCP lattice, edge length is given, calculate density. Density we want to find out, formula you know, Z into m divided by a cube into Na. A is given, edge length is given. Okay, density is given, density they didn't give. 107.9 is nothing but this value is m. M is given. For CCP it is what is the value you know, Z value. M value is given, a cube is given, n value, Na is given. Find out d value, that is density, and send your answers to me. This is homework question you want to do. Next one, lithium metal has a body centered cubic structure. This is BCC substance with edge length is given, that is a value 352 picometers. It is given in picometers, convert it into centimeter, multiply it with 10 to the power of minus 10. Calculate density, again it is related to the density. The d equals to Z into m divided by a cube into Na. A value is given 352 into 10 to the power of minus 10 whole cube. Z value for BCC you know it is 2. Then m value you want, m value is also given, that is 7 grams per mole. This is m value. Na is a constant, 6.022 into 10 to the power of 23. Substitute all this and find out d value. Even this is homework for you. So find out these two and send answers to me. This is about the most important concept what you want to concentrate in the chapter solid state. This is enough. Whatever the questions I have given, you just make a look of it, and I'll post the questions related to this chapter for 2 marks and 3 marks. There is no 1 mark question from this solid state.